Hello guys, welcome to today's class. So today we'll be talking about implicit differentiation and how to differentiate implicitly. So far we have treated relations of the form y. We've treated relation of the form y equal to f of x. So example of such relations can be that we treated was y equals to 3x squared minus 2x plus 1, and also y equal to 1 plus root x. So far we treated relations like this. So in any of these relations, y is said to be expressed what explicitly. So in any of these relations, y is said to be expressed what explicitly in terms of x. And the derivative of y with respect to x can be found from the rules of differentiation, which we have discussed on our previous topics. So sometimes the relationship between y and x may not be expressed explicitly. Relation between y and x may not be expressed what explicitly. So for example, if we have something like x squared y plus xy raised by 3 plus 3x equal to 0. So for example, if we consider something like this, here the relation between y and x is not expressed explicitly like this. So you can see that x and y are together, product is binding them together. So the relationship between y and x is said to be implicit. And in differentiating x square y plus xy raised by 3 plus 3x equal to 0, y is treated as if it is function of x, and the rules of differentiation are applied in the appropriate manner. So the process of differentiating this, or the process of differentiating implicit function, is called, this is an implicit function, and this is an what? Explicit function. So the process of differentiating this, it is called what? An implicit differentiation. It's called an implicit what? Differentiation. So now I'm going to teach you on how to differentiate implicitly. So the question says differentiate each of the following implicitly. The first question, x squared plus y squared equals to 4. Differentiate this implicitly. And also the next question, x squared y plus y squared x plus 4x equals to 1. Differentiate also implicitly. So from the first question, x squared plus y squared equals to 4. So differentiating terms by terms with what? Respect to x. If you differentiate this term by terms with respect to x, if you differentiate x squared, you have 2x. And whenever you differentiate y, we differentiate y squared, we have plus 2y, and you add what? Dy over dx. So whenever you differentiate y, you add what? Dy dx equals to, differentiate 4, which is a constant, you have what? 0. So now if we move positive 2x to this other side of the equation, we are going to have a negative 2x. So we can say that 2y dy over dx will be equal to negative 2x. And now how to take 2y to this other side is to divide both sides by what? Divide both sides by 2y. We are going to have that dy over dx will be equal to minus 2x over 2y. So 2 can cancel 2. We are going to have that dy over dx is equal to minus x over y. So you see, this is how to differentiate implicitly. Whenever you differentiate it, you are going to differentiate terms by term with respect to x. And whenever you differentiate y, you add to the y dy dx. So now let's attempt the same method, attempt the second question. Feel free to pause the video and try the question on your own by yourself. That's how you learn quickly. So if you differentiate the second question, 10 by 10 with respect to x. If you differentiate x square, you are going to have what? Differentiate x square, you are going to have what? 2xy. Differentiate x, you are going to add 2x. So if as you write the 2x, you add the y, 2xy. So remember, you now still differentiate y again. Don't forget, whenever you differentiate y, add the y x. So you differentiate y, you have 1. Remember, if you differentiate y, you have 1. So you add the 1 times the 2x. 1 times 2x squared. Sorry, 1 times x squared gives you what? Plus x squared. Remember, whenever you differentiate y, you have what? The y over the x. Plus y, differentiate y squared. So if you differentiate y squared, you have 2yx. You have 2yx. Remember, whenever you differentiate y, you add what to it. So for example, if you differentiate 2y squared, we have what? 2yx. Don't forget that whenever you differentiate y, you add to it what? The y over the x. So now you differentiate x, you have what? 1. So you add to the 1, you use the 1 to multiply y squared. So you have what? Y squared. Just what? Y squared. Because you are not going to add the y the x, since you didn't differentiate y's, but you differentiated what? X. So now the next time, if you differentiate 4x, you have what? Plus 4, and equal to, remember, you differentiate 1, which is a constant, you have what? 0. So now let's collecting like terms, taking wherever you see the y the x one side, and so we have that 2xy plus y square plus 4 plus x square plus 2yx dy dx. Hope you know how I got this. So this is x square and this is 2yx. So I just factorize the y dx stays outside. So the y dx can multiply everything, gives you this. And this is 2xy. This is y square. This is plus 4 plus 4. So now, if we take everything here to this other side of the equation, we are going to have that x square plus 2yx dy over dx will be equal to, so this comes there, gives you negative 2xy, also plus y square comes to give you negative y square, plus 4 crosses this coefficient and comes to give you negative 4. So now we can divide both sides by x squared plus 2yx to get dy dx. So dy dx will be equal to minus 2xy minus y squared minus 4 over x squared plus 2yx. So now this is how to differentiate what? Implicitly. This is how to differentiate what? Implicitly. So now you know that whenever you see that relation of this form, just know that it is what? Implicit differentiation. And whenever you see relation of the form that y is equal to something like 3x squared, that y and x are not together, just know it's a explicit what? It is in the explicit form. Why this? Something like this, x squared y, something like x squared y plus 2yx. Just know it is what? In a form of what? Implicit. So on our next class, we are also going to solve some problem on implicit differentiation. Please like, share, and subscribe. See you on our next class.